Hey guys, welcome to your Unit 5 Lesson 2 notes on writing equations in point-slope form. By the end of the day, you will be able to write a linear equation in point-slope form. Let's get started. Our key idea of the day is that you can use the coordinates of a point and you can use the slope of a line to write its equation. So you need two things to write an equation. You need a point, which is going to be a x, y coordinate, like that. And you need the slope. Remember that the slope is m. But don't take my word for it. Let me prove it to you. So remember what slope is. Slope, we say m equals, and then you need to find rise over run. You need to find the change in y over the change in x. So what that means is you say that m equals the difference in the y's. So you find the difference, literally you subtract. That's what difference is. And then you also find the difference in x's. Okay, cool. So we know this. We know this is the definition of slope. But what happens if we mess with it? What happens if I notice, you know what, I'm going to take this x2 minus x1, and to clean this up, I'm going to multiply both sides times x2 minus x1. Remember the multiplication property of equality? It means as long as I multiply both sides by the same thing, then I'm okay. Because this x2 minus x1 and this x2 minus x1, they're going to cancel out, leaving me with just this. Leaving me with x2 minus x1, x2 minus x1 times m equals y2 minus y1. Okay, super. And then, to make it pretty, I'm going to switch these guys around real quick. Okay, excellent. Get it? Because x is ha. Okay, cool. Anyway. And now, this is technically a definition when we know 2 points. We know what x2 is, and we know what y2 is. But what if I want this to work for literally everything ever? I want it to be super general. I'm going to replace x2 and y2. I'm going to get rid of the 2. Whoops. Whatever. I'm going to get rid of the 2 and just have x minus x1 and y minus y1. I'm going to leave those alone. Scoot this over. And I have my slope. I have points. I've got x1 and I've got y1. And that's the formula for a line. Isn't that super cool? That's super cool. We can take this guy and then keeping our x the same. As long as we plug in, hey, I've got a x1 and I've got a y1 in my point. That's it. That's the formula for a line right there. We call this guy point-slope form because he's got an xy point. That is x1, y1. And we've got a slope, m. So as long as you know what your x1 is and you know what your y1 is, you can write the equation of a line. I'm going to take our point-slope form. I'm going to just put it right there to have it for a good memory. And I'm going to copy it because we're going to use it all the time. Okay. Point-slope form, remember, m times x minus x1 equals y minus y1. So we want to graph the line that passes through that point and then write its equation in, point-slope form. Got to rewrite point-slope form. Nice. Okay, well, what do we know? We have our point. Remember, points are always x, y. So that means -3 is our x value here, and 2 is our y value. So if I want to graph it, they seem like normal numbers. I'm going to first remember to label my x-axis. Excuse me, and then I'm going to get the hiccups. And then I'm going to label my y-axis. And the key word today is dynamite, by the way. So now I have my point here, -3, 2. So x is -3, go back 1, 2, -3. And then I go up 2. So up, oops, that's too far. Up 2. So my point is here at -3. My x value is -3. My y value is 2. And then they intersect right at this point. There. Okay, so I've graphed my point. Excellent. And remember, slope. Here our slope is 2. So slope, remember, is rise over run. That is how far up it goes and how far over, how far right it goes. So if we start at our point and we know our we know our slope is 2. Remember, you can write 2 as 2 over 1. So we go up 2 over 1. So I'm going to draw myself a little path right here. Go up 2 over 1. And that's where my point is going to be. And then we need to go up 2 over 1. It's got another point right here. And then we go up 2 over 1. So we've got another point right there. And now that we've got several points, we can connect them all. And hopefully if we did this right, we'll get a nice straight line all the way through. We did. Excellent. Kind of looks bent, but it's a line. We'll count it. Okay, so we graphed it. And now we need to write its equation in point-slope form. Well, we have all the information we need. We know our point and we know our slope. So let's just plug it in. Our slope is 2. And we keep x minus the same. Our x1 is -3. I'm going to run out of room because I'm writing too big. I'm going to scoot it over. Yep. Okay. Equals y minus, and then what's our y1? Our y1 is 2. Yay! We can clean this up just a little bit, just a little bit. I'm going to see this minus. I'm going to count that as plus. So we have 2 times x plus 3 equals y minus 2. And that's it. We're done. We don't solve for y. We don't figure out what x is. That's it. We just write the formula of our line. All set. Okay, wasn't that so fun? So good. Okay, cool. Yeah. So now, let's do it again. This time, instead of having a graph, we're just going to use our 2 points. So let's get our point-slope form back here. Okay, awesome. We need to find the slope line that passes... Oh, you guys, we don't know what our slope is. We need to figure out our slope. So before we can use our point-slope form, we need to actually find what our slope is. So our first step, find slope. Oh, it literally says, find the slope of the line. Ha 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 ha. Okay, so that'll be our first task. Find slope. This is why it's very important to read the directions, you guys. Okay, and let's label these as x1, y1, and x2, y2. Could we have switched it? Could we have done this instead? Said, hey, you know what? That's x2, and that's x1. We totally could have. But we're going to count it. Okay. So for the formula of slope, remember slope is rise over run, which means it's your y's over your x's. So I'm going to plug those in right away. y2 minus y1 over x2 minus x1. And then I'm going to simplify this. 1 minus 1 is 2. 0 minus 3 is 3. So our slope is 2/3. Hey, we did it. Our slope is 2/3. Super. Okay, find the slope. Then write its equation in point-slope form. Hey, now we've got our point-slope form. So now we can write equation. But wait, we have 2 points. We were given this point and that point. Which one should we use? It doesn't matter. Let's do the first one because it's first. Okay, so what's m? Well, we just figured out that m is 2/3. I forgot to put my phone on silent. Oh well. So x minus x1 is -3 equals y minus y1 is -1. Super duper. Let's simplify that just a little bit. So we have 2/3 of x plus 3 equals y plus 1, because remember when you subtract a negative, that's the same thing as adding a positive. So that's really cool. So that's it. That's our formula. Some people, you might see that these are switched around, that they switch what's on the different sides of the equal sign. They like to put their y's first and then their x's on the other side. And that's totally fine because we say equals is reflexive, so you can reflect it like over a mirror and it's still the same. If that was super confusing, don't worry about it. Okay, yay, we did it, we wrote our equation, but now we need to check our work using the other point. So we're going to take our equation, and we're going to take our last point that we didn't use, since we used -3, -1 in our first one, we're going to check with 0, 1. And what we're going to do here is we're going to take our x and our y, and we're going to plug them into x and our y. And that should give us a true sentence, a true mathematical sentence. Is it true? Is it true that 2/3 of 0 plus 3 equals 1 plus 1? Question mark? Is it true? Well, I don't know. Let's figure it out. So easiest, 0 plus 3 is 3. 2/3 of 3, is that equal to 1 plus 1 is 2? I feel like that's the most basic math ever. 2/3 times 3, those 3's will cancel out, giving us 2, and 2 is 2. Yay, make Noah's Ark proud. Got 2 by 2. Ta-da! Cool, we did it right. Way to go. That's great. When are we going to use this in real life? Well, let's say that you want to predict a long jump distance, height, distance. Long jump is lateral, side to side. Okay, well, in the 1988 Olympics, the women's winning long jump was 24.7 feet. Oof, guys, that's so far. That's like 10 yards. Oof. Someone predicted that by 2024, the world record would be 26.3 feet. Ooh. In 2016, the winning jump was 25.5 feet. Are the women on track to set the new record? Well, I don't know. How are we going to solve this? I'll tell you. First, we'll write an equation. Then we'll graph the line. We'll graph that equation, and then we'll graph that score as a point and see where it lies. Okay. So let's first write an equation. Here we need, in order to write our equation in point-slope form, we need to figure out what our points and what our slopes are. Okay. Remember from yesterday that our x's are usually going to be time. That's our independent variable is all about time. So here our time is years because we're looking at 1988 Olympics, we're looking at 2024 Olympics, and we're looking at 2016. Okay. So what's our other data point that we're talking about? Well, we're talking about the jump length. Distance? Yeah? Okay. Cool. So here we go. Oh, yeah, I didn't label it. Y is, how about just distance in feet? Cool? Cool. So we're going to use the 1988 score and the 2024 prediction and write them as points. So in 1988, that's our X. We have 1988. And then the distance jumped that year was 24.7. So that's 1 point. Man, guys, that's a good point. Haha. Okay. Well, here's a counterpoint. In 2024, the world record would be 26.3 feet. So our X is 2024, and we have 26.3 feet. Okay, nice. So we have 2 points, and now we just need to figure out what our equation is. Okay, so first let's plug in our slope. We don't know what it is. Let's find our slope. Okay, so remember slope is rise over run. That's the difference in our y's over our difference in our x's. So that's the same thing as 26.3 minus 24.7. Because remember, to find a difference, you subtract. So the difference between 2024 and 1988. Great. Now we just need to simplify what that's all about. Okay, here we go. So where am I? Oh, here I am. All right, cool. So we have 26.3 minus 24.7 is 1.6. And then 2024 minus 1988 gives us 36. Now remember what these are all about. This is like feet jumped, and this is years. So on average, they are jumping 1.6 feet farther every 36 years. So chew on that for a while. If you're curious, that comes out to approximately 0.444444, because this averages out to 4 ninths. Is that right? Nope. 4/90ths. But we're going to go with 0.4 because it's close enough. All right? Cool. Cool. Alrighty. Now we need to graph our line. Well, here we go. I'm going to show you something that you never need to do in my class, and it's called breaking your axes. So here, what we're dealing with, guys, is we have this point 2024, and we don't want to go all the way out that far. We don't even start at 0. We start at 1988. So we're going to break our axis. We're not going to go all the way from 0 and then like 1,000 and then 2,000, because we'd just be working in this little space, and we don't want to work in just this little space here. We want to work across our whole graph. So in breaking our axis, that gives us permission to just kind of slide the numbers over, if that makes sense. Anyway, if it doesn't make sense, just put that little squiggle in. And let's put 1980 here. Let's say this is 1990. We've got 2000. Going by tens, right? 2010. Oh, shoot, that's 2020. That's not going to be far enough. We need to go to 2024. Redo. How are we going to figure this out? Oh, I know. Oh, you guys, I totally know. Watch this. Boop. And the only reason we're allowed to do that is because we put this little squiggly in. Okay, cool. Now what are our y's dealing with? Our y's go from 24.7, 26, 25, 24.7 to more than 26. So let's make this scale, how about 24, 25, 26, and 27. Super! Okay, now we have 3 points that we need. We need these 2 points, and we also need what happened in 2016. In 2016, they jumped 25.5 feet. Okay, now we've got 3 points. So we can graph our line, or here, it's time for the cheater method. Since our line goes between these 2 points, let's just put those 2 points in and then connect them. So we go over to 1988, which is going to be like here-ish. Yep. And then we have it goes up 24.7, which is going to be like there-ish. Yeah, sure. So there's our first point. Let's label it. Cool. And then we graph 2024 and 26.3. So 2024 is going to be like here. Yeah. And 25.5. Oh, that's so nice. That's right here. Oh, just kidding. That's the wrong year. 26.3. We need 26.3. 26. About there. There's our point. And now that we've got our 2 points, we can make the line by literally connecting them. Ta-da! Isn't that great? Okay, now finally we need to figure out, were they on track in 2016? So we find the year 2016. It's the year I started working at Whittier Christian. Fun fact. Right there. And there's our 25.5 right in the middle. Uh-oh. You guys. That's not a good sign. Why isn't that a good sign? Because if we want to be on track, we need to be on the line or even above it because we want to do better, right? But because we are underneath the line, we are not on track. Oh no. That's okay. Work hard. It's been a rough year. Ta-da! So the question is, are the women on track to set the new record? No. They're too low. But we still believe in you. Okay. So, to write something in point slope form, you need a point, you need a slope, and you guys, this form right here, super important. Memorize it, write it at the top of your homework. Love it. Dream about it. And your wildest dreams might come true. Hey, have a great time on your homework.